All right, hello and welcome to the programming lecture. So this time we're going to do that fancy 2D bouncing now with our turtle. It's going to bounce off all the walls two-dimensionally and move around. Okay, so that's what we're going to do. And we've already filled out these slides last time, but let's just briefly go back through them. So what we're going to do is we're going to draw the screen as usual. We're going to put our turtle somewhere randomly in the middle, and then we give him a random direction to start moving in, okay? And then we finally have a loop that says forever loop, please keep moving in your current direction unless you hit a wall. If you hit a wall, you gotta bounce off, okay? And you gotta keep bouncing every time you've hit a new wall. So that is the game plan. So there's gonna be a loop, there's gonna be an if statement inside of that loop. That is the idea. And if we ever hit a wall, we gotta bounce off in a certain way, just like we were bouncing off the top when we were doing the top and bottom when we were doing the just one axis bouncing ball. Yeah, that's the idea. So again, we are going to do a few things at a lower level. Of course, we're going to make the turtle into a square, and then he has some coordinates that we can use to figure out where he is. And the way we're going to move him, again, is if that's supposed to be his direction, we're going to take and pick that, pick out of it an X offset and a Y offset. Because if you move him along the X offset in the X direction and the Y offset in the Y direction, he will end up in the place you want him to end up in that original, non-perfectly set to the axis direction, okay? So that is essentially the idea. Each frame, just like we were before, we're going to move the turtle a little bit, but we're going to move him a little bit on both axes. So a little bit that way and a little bit that way, which is going to, together, bring him in that direction. Okay? So yeah, every time you have a direction, you have an offset in both the X and the Y direction, because we're doing it in 2 dimensions. Okay? So yeah, the last piece of the puzzle that we talked about last time was like figuring out how the turtle hits the wall. So let's briefly talk about that. So we got to figure out when is that turtle going to hit the wall, and it just so happens, I think, that if we check for his coordinate to be, like his X coordinate to be -180, that's when he's past it, because when his middle is at -200, he's already over the edge. So I think if we figure out if his X coordinate is less than or equal to -180, I'm pretty sure, one of those, that'll mean he's right on the edge, and that's when we stop him and bounce him. Okay, so that's the same thing happens for the top wall. If he's coming in that way, if he's coming in this way, that means the Y coordinate is like greater than 180. Okay, so yeah, whenever you want to bounce, you negate the offset. So this is the X offset, it's the Y offset. You want him to bounce this way, so you just negate, X offset was that way, now the X offset becomes this way, and the Y offset was the same. Okay, so that's bouncing. That's all you have to do to bounce a turtle. So with that, let's get started. Let's do this. I'm going to use this scratch page to draw things, but our starting point is going to be our original bouncing turtle, just up and down. Let us move now then to the code. So I have copied our very first bouncing program, and I'm gonna make a wild guess and say that this is lecture 27. Is there room to make a new folder? We'll find out. Yeah. Okay, so I'm gonna call this 2D bounce, I guess. This is gonna be the one. So right now, it's just the stuff from last time. It's bouncing up and down ever so slowly. Okay, straight up and straight down. It's that program. All right, so let's make it bounce a bit slower for now. We'll deal with that later. Yeah, okay, so it's bouncing all around, up and down, up and down. And this is almost what we need, but we need to consider the next axis, okay? So right now, what we have is a program that draws the screen, makes the turtle into a ball, and I guess I misspelled that, sorry. Then we changed its color, because why not? It's double the size in both directions. And then we are putting the turtle in an almost random location, right? We're putting him in the top. but the x coordinate is random. Okay, so let's make it a completely random spot inside of the inside our little bounding box. Okay, so it doesn't matter where the turtle could start, up here, could start over here, over here, over here. Okay, so it needs to give to get a random spot, an x and y coordinate within this box, which is 200 by 200. Remember? Or sorry, it's 400 by 400, isn't it? That's going to be useful to know. And so 0, 0 is in the middle. And the maximum point that we could like put him is up here. And because of his like 20 width, or maybe it's 40 width, I'm not sure. I think the max coordinate we could ever give him for x is going to be positive 180 and positive 180 for the y as well. I think that would be right in the corner. So with that in mind, and this would be the lowest possible coordinates for both of them, I think it would be negative 180 and then negative 180, x and y. Because we don't want negative 200, because then he'd be outside of the box. Okay? Because his coordinates are based on his center, I think. So let's give him a random x and y location within the box. Okay? Move turtle into a random spot inside the bounding box. And so turtle x and turtle y can be random, negative, I think 180, positive 180. And then the turtle y can be the same. Okay, so now he's going to start in a random spot, a random y coordinate as well. Okay, random x and y coordinate. All right, and then we're going to move him there. Okay, I guess these 5 lines kind of go together. And then we have to worry about this offset. Okay, because we need to pick the direction now. Okay, pick a random starting direction. For our turtle. And, okay, well, we could do this. This is fine. This is like an x offset. We also need a y offset, okay? So that is pick x and y offsets for the turtle. And let's let the offsets be between, like, 0 and like 2 and 0 and 2. So the biggest offset is 2, 2. I think that might work. But we also want negative directions too, don't we? So let's have, I don't know, let's have the x and the y offsets be between 1 and negative 1. Yeah, how about that? So the direction is based on offsets. We need an x direction and a y direction, okay? Those offsets will represent the x direction and the y direction. Okay, so what we need now is turtle, or maybe we can call it offset x and offset y. And these should be random numbers between like negative 1 and 1, okay? Because they can go that way, that's negative 1 and positive 1. You could go that way, that's positive 1, positive 1. You could go that way, negative 1, negative 1. You can go that way, and anywhere in between as well. That's negative 1, positive 1, and negative 1. Okay, so this will make more sense once I do it, I promise. So we need random dot, not a rand int anymore. We need like a uniform random number. So I think I should go back, not Python turtle anymore. We can save that as well, but we need Python random. Yeah. So let's go to the random page and let's look at how to get random floats, not rand ints. Okay? Let's see here. Sample, shuffle, random. Aha, uniform. That'll do it. Because random.uniform between A and B, you'll get a random float between those two numbers. So if I say import random, random dot uniform between -1 and 1, every time I do that, it'll be a different random number that's a floating point number, see that, with the decimals, between -1 and 1. Isn't that nice? And eventually it will go back to being positive again. No, it doesn't want to copy. I have no idea why I didn't copy, and I'm sorry. Okay. Copy. Okay, yeah, it's really not happy. Oh well, but I think you get the idea. Okay, random.uniform. And this is going to be -1 and 1. And just to represent the fact that they can be decimal numbers, let's put 1.0 for fun. So now offset x will be a random number between 1 and 1, and offset y will be a random number between -1 and 1. All right. So one thing that, unless you've taken like vector calculus, won't make a whole lot of sense to do, but it's quite possible that the turtle will be moving very slowly. Like maybe his direction is in the 1, 1 direction, but he's like, it's like 0.5 and 0.5. And so he's still moving that way, but he's not moving as fast. We'd like the turtle to move as fast as he wants in all the directions. So we should like stretch out his direction to be of size 1, okay? Instead of like 0.5 or something like that. We want to stretch out that direction. And the way that you do that is you do what's called a normalization, okay? So we're going to get the current length of this. It's called a vector. You don't have to really pay attention to this, but it's going to help in just a second. Normalize offset x and offset y to be of length 1 when considered together. Okay, so this makes it so that the turtle can only ever point somewhere along a circle. Okay, so the turtle's location can be going that way, going this way, just as fast in each direction. You can't have something like that. Okay, the idea is we want to make sure that he's always going at the same rate in each direction. So we want to normalize these offsets. All right, so the factor that we normalize by is going to be like the length of this direction. So you say math dot, and I think I have to import math. I don't know. Import math. It's going to be math dot square root of offset x squared plus offset y squared. Okay, and so this is like the length of this arrow, this direction arrow. It's a length because it's got an offset x and an offset y, and it's just Pythagorean theorem to find the length L. Okay, so this is like the length, and this is therefore our normalization factor. If we just divide offset x and offset y by this factor, it will be of length 1. Okay, that's how we do it. Offset x equals whatever it was divided by that. And if this makes no sense at all, you can delete this code. It's not going to make any real difference, though the turtle might start out going very, very slow, because maybe it's like 0.25, 0.25. We want to make sure he's always going the same speed every time, no matter the direction he starts in. Okay, so that is the idea. He will be of length 1, and that should be that. Okay, so now we can use offset x and y as our direction. So now, moving the turtle by offset x and offset y will move him 1 unit in his current direction. Okay, so now comes to this loop. We're getting there. So what we do is we want to move the turtle, right? So this is what this was doing. Move the turtle in his current direction. And this involves changing the y and x coordinates this time, because he's moving in 2 dimensions. So the turtle y changes by offset y, and the turtle x changes by offset x. Okay, there's that. And then we see if we hit a wall, and bounce if we did. So we were keeping track of the top wall. That's the top wall's y-coordinate. And this is the bottom wall's y-coordinate. We also need the left x-coordinate and the right y-coordinate. Okay? Left x and right x still, sorry. Dun, dun, dun. So we got top, bottom. Let's do left x and right x. Because the reason we know that the turtle hit the left wall has nothing to do with the y-coordinate. It's all about the x-coordinate over here, right? Left x, right x. And so it's really just a bunch of 180s and negative 180s, but that's okay. We're getting there. Okay, so this is the left wall's x-coordinate. And this will be the right wall's. Let's see, right wall's x-coordinate. Oh no, I got them backwards. This is right. And this one's left. No, this one's the negative one. Okay, so swap those and we should be in business. Okay, so again, every time we take a step, we want to move the turtle a little bit. Okay, where's that? Move the turtle in the current direction if there's nothing in our way. So we're good. We're going to try and move the turtle, okay? In the current direction by changing his offset x and his offset y. He'll move just a little bit, depending on his current direction. If he's going this way, he will go from here to, like, this place. Okay, that's what happens when you add the x-coordinates direction offset and the y-coordinates direction offset. Okay, lots of words, lots of little pictures. Do yell at me if any of this is not making sense. Okay, so this is where we know the walls are. Now we need to check if we hit them. Okay, so I guess this is more like here where we make that check, and this is like figure out where the walls are. Yeah, I think that's a better place to put that. So we're going to now see if we hit any of the walls. And it's going to be a bunch of if statements, not if, elif, and else's, because it's possible, like the example from The Office, to both hit the top and the left, or the top and the right. Yeah? So we want to try all of them, see if we hit any of them. Okay? So this is all essentially the same. If we hit the top wall, you move the turtle down to the top, and then we change his what direction, okay? So he just bounced off the top wall. Maybe he was going this way. Do we change his x offset? It's going that way. Or the y offset, which is going that way. It's going to be the y offset, you see? The x offset stays the same. Keep going to the right-ish, but now you're going down 2 instead of up 2. See that? So that's how you bounce off a wall. You change your y direction. X direction stays the same. So it's offset y that we change now, and we negate it. Okay, and so it's offset y for the top and the bottom. Okay, changes direction to invert his y direction or something. Okay, so this is the top wall and the bottom wall. Okay. Hit the top wall, hit the bottom wall, and now we need to check, because it's very possible we're over here, check if the turtle hit the left wall, and check if the turtle hit the right wall. So again, it would be another if statement. So if turtle x this time, because the x determines whether or not we're over here or over here, if turtle x is less than left y, left x, sorry. See that? Because this is the left x, it's negative 180. We gotta see if we're trying to go outside this wall a little bit. If the turtle tried to go even farther to the left past the wall, that means his x-coordinate was even smaller, then we gotta move him back, okay? Move the turtle back to the edge on the left. So turtle x equals left x. and then we're going to invert his x direction. Because if he was coming straight this way, of course, you're going to invert the x direction to make him go straight that way. Or if he's coming off in an angle, like maybe he's coming that way, we want to keep the same y direction, but invert the x direction, because x was going that way, and now we want the x direction to go that way. Hopefully that's making some sense. That's how you bounce off the side walls. You invert the x direction, which is offset x. Set it to be whatever it was times -1. Okay? And this is essentially the end, because if we hit the right x wall, how do you know if you hit the right wall? That means the turtle was over here, and his x-coordinate was a little too big. It was past whatever x-coordinate was for the right wall. Okay? So it's greater than right x. You see the difference? You hit the left wall if you're less than the left x. You hit the right wall if you're greater than the right x. Okay? Just got to draw some pictures and it all will make sense. Let's see if I can keep that there. Yeah. So if we hit the right wall, we're going to move him back to the edge on the right. And we're going to change this, of course. But the inversion of the direction is still the same. It still needs to be inverted. It doesn't matter, because you hit the right wall if your x direction was positive, and you just make it negative by multiplying it by 1. And you hit the left wall if your x direction was negative, you just make it positive by multiplying it by -1. So you can keep the same thing. This line can stay the same. Yeah? Hopefully that's not too bad. And then actually moving the turtle hasn't happened yet. That happens at the very bottom of this loop. See? Right here. Because we've spent so much work trying to figure out where the turtle should even be. Move him a little bit, see if we hit a wall. That was our game plan. So we moved him a little bit, and now we got to see if he hit a wall. Okay? And this is how we do that. And yeah, then we go to turtle x, comma, turtle y at the new location. Yeah? Moment of truth. Let's see how wrong I did it. All right? So again, turtle is going to, after we draw our screen, is going to become a ball. Actually, let's make him a square. Whee. Let's make him a square this time. Why not? Because I've been drawing squares all over the place. And then he's going to be giant. He's going to move to a random location. We're going to make sure that his direction, we get a random direction as well, and we make sure that direction is of unit length. Then we repeatedly move him and bounce him if he needs to be bounced. Okay, so I don't see immediately any errors, so we're going to run this and see what goes wrong. So you see, he's moving up and to the left. So we got now up and to the right. So a positive y and a positive x direction. Not very exciting because he's moving very, mostly horizontally right now. But I can rerun the program, of course. And now he's moving a little bit differently. See that? And it's so satisfying how he bounces off the wall like that. Oh yeah, almost in the middle. And we can make him go faster because of what we did here. We can make the turtle move faster by, because we made these of unit length, we can just multiply them, okay? Okay, let's see here. How do we want to do that? So, make the turtle go faster by making the direction arrows length larger. So you can say something like this now. Let's make him go twice as fast. We're going to make the direction arrow for the turtle twice as big by multiplying like that. Okay, so let's see what this looks like. Might be a bit more exciting. Ooh, that one's almost straight up. Isn't that cool? That's nice. Okay, that's 2. Let's try it again. Almost straight up again. Wow. All right, let's try 3. 3 speed. Oh, that's looking good. Look at that. That's like almost Pong. And that is our goal eventually. We want to make Pong again. Okay, so now we've got our ball, essentially, moving across, bouncing off all the walls. Isn't that glorious? So, it just took a little bit more than what we had before. Most of everything stayed the same. It's just we considered the y as well as the x as well as the y. Okay. There's some fancy factoring going on here. Technically, this is not necessary. Again, I'd be happy to explain it to you if you haven't taken like a physics or a vector calculus class yet, but it's useful. It's useful for this reason. Okay. Yeah, that's essentially everything I wanted to show you here. One thing that I'd like to do is emphasize how nice functions are, because instead of all this, like cluttering up the bottom here, making it hard to reason about, you can just say bounce. Bounce if, I don't know, if hit wall or something. You can make a function. Just like we made a draw rectangle function up here, we can make a bounce if hit wall function. Yeah? Yeah. And all of this gets, you can stay up here, it's totally fine. See how much easier it is to reason about this while loop now? Let's maybe make sure that we talked about this somewhere. Make a bounce if hit wall function. So that you can kind of understand where we were going. Okay. And everything stays essentially the same. One thing that you do have to do with this function is it's not going to work exactly as it does right now because of these variables. These variables exist outside. They're down here, places, turtle x, turtle y, offset x, offset y. And so what you have to do to be able to use those variables is you have to say that they're globals, okay? So we have to tell Python that the variables we're about to check exist outside the function. So variables that exist outside functions are called global variables. Everybody can see them. Okay, so we just have to say, tell Python that these are all global. Global turtle y, okay? I think I can use commas. If I can't, it'll complain in a second. Let's see if I can do that. Is that happy? Oh yeah, cool. So, yeah, see what happens if I don't tell it about all this stuff? It's like, what is turtle x? It doesn't exist. It's referenced before assignment. What are you doing? I gotta tell it about it. Turtle x, top x, offset y. Or, sorry, bottom y. What else? Is that enough? I guess so. Yay. So it's happy. It's happy again. And we split stuff up into functions, which is always nice. Ooh, that was almost in the corner. Okay. So that is everything that I wanted to show you there. That was the bulk of this lecture. The last cool thing that I want to show you today to prepare for Pong, because our goal is Pong. Okay, goal. Pong. Okay, we're almost there. We just made the ball. So we need to move our little paddle. If we're going to make Pong, we want to make a paddle, right? And it needs to be moved up and down, hopefully by our keyboard presses. If we press up, it moves up. If we press down, it moves down. So what you do is Turtle can listen for key presses. And we can say turtle.onKeyPress. Okay? So that is what we do. And we also have to say turtle.listen to tell the turtle to start listening to the keyboard. So both of these. We use the onKeyPress and the listen to tell the turtle to, hey, listen up, I'm about to press a key, pay attention. Okay? So let's make the paddle, and yeah, let's do all this. Let's use key press. Where'd it go? On key press. Oh, sorry, I'm in random, aren't I? Key press. There it is. On key press and listen. So yeah, it'll look like this. We'll say do something with the up key and then start listening for the up key. Okay, So I guess I'll keep this one open, and let's make a paddle. Yeah. So we're gonna import. Might as well just keep all this. Might as well keep all of this, and draw a rectangle. Let's make sure to do that. Square, pink, big sized, sure. Actually, that's enough for there. All right, so this is paddle.py, let's say. And so what this is going to do looks like this. Make the turtle large. Turtle's up there. Let's put him in a spot that is normal looking, so maybe oh no. Let's play around with this. Let's get out of that. Let's put him like in the middle a little bit. Turtle. Up. Turtle. Dot go to will work. Let's do like -160 or something, and then kind of in the middle, 160 maybe. How about that? Does that look like? That's a good spot for a paddle, I think. And now, because it's the paddle, we can stretch him a little bit more in the vertical direction. And so that's one of these. I can't remember which. Let's try this one. That might be the vertical direction. Yeah. Okay, so let's make it like, I don't know, 10? 10 in the vertical direction? Not 105, that's for sure. That's a little too big. I don't know, 7? That still looks a bit large. How about 6? I'm happy with 6. Okay, and then the paddle looks a bit fat, so maybe we can make it like 1.5 or something. It's just fun to play around. That looks like a nice paddle in a nice spot. Maybe a little bit farther to the left, like 170. That looks like a perfect paddle to me, yeah? We can play Pong with this. So now, what we want to do is associate the up key press to move this turtle, remember it's still a turtle, up, and then the other key press to move this turtle down, okay? So let's have the up key move the paddle up, and remember the paddle is just a turtle, and the down key move the turtle down, okay? Paddle down. And so the way you do that is with these functions. You say turtle.onKeyPress, okay? So turtle.onKeyPress, and then you need some kind of function to go here, and then you say up. And what this does is it calls the function, I don't know, move up. We'll make that function whenever the up key is pressed, okay? That's what that does. And maybe we can put it like this. Yeah. Okay, so we have to make this function. It just is just associating this key right now. It's saying, okay, you press the up key, I'm going to call this function for you. I can do that. And then we'll do the same thing for down, when you press down. And we'll make a move down function. Yeah? And so all we have to do is make these functions to actually go and move the turtle. Let's say def move up. And let's see if it needs to take any parameters. No, it doesn't. Cool. So move up, and then we'll just say turtle dot, I don't know, how do we want to do this? Let's get his, let's just do it all out. Turtle dot get pause, I think? Yeah. So let's get his x and y coordinates. Equals turtle dot pause, I think. Let's make sure of all that. Yeah, turtle dot position gives back those coordinates. Cool. So that's x and y. So we want to change the turtle's y, okay? So the new y is whatever the old y was plus, I don't know, 5 or something. How does 5 sound to us? And then turtle.goTo, same x, new y. Yeah, so that's moving up. And then we'll do something similar for down in a second. Key press. The other thing that we have to do is tell the turtle to start actually listening for the key presses. And so we have to say this, turtle.listen. Do not worry about this screen thing right now. You can just say turtle.listen, that works too. Start listening and responding to key presses, please, Mr. Turtle. So now I've hooked up move up, and I think it's going to complain, actually, if I don't write move down. So let's write move down too. Whee! And so for moving down, you want to take the y and subtract from it. Whatever it was, minus 5. If 5 works for us. Yeah! And so I'm pressing up, pressing down, it moves a little bit. Moves a little bit, hold it in, it moves even more. And 5 now seems like it's a little too slow. So let's do 10. Isn't this fun? This is a paddle now, guys. Look at that. Look at that. That's glorious. That is beautiful. We can play around with the speed, how fast it should be, how fast it shouldn't be. But there is a problem right now. Oh no! I can do it in the same direction up here as well. So that's something we need to watch out for. Okay? That's the last problem here. So we want to make sure that he stops on the bounds. Again, just like this stuff that we were working on. We need to make sure the paddle stops, darn it. So it's all the same stuff as before. We just need to worry about it. Okay? So let's see what we can do. We need to stop the turtle from moving even more up if he's already at the top. Okay? So if new y, let's just write it in English right now and then we'll fix that, is past the top, then new y equals the top, right? That's what we need to do. We don't want to let him go any farther than the top, okay, wherever that is. So being past the top is going to be greater, and I have no clue where the top is because the turtle is really stretched right now. So here's his middle coordinate. I'm not really sure how big this direction is right now off the top of my head. We can play around and figure it out. So looks like 6, probably 6 times 10, right, is maybe 60, 120. I would bet money on 120. All right, so let's try that. If new y is greater than 120 or something, new y equals 120. Well, let's try that. Who knows if that's going to work, though. It's a little bit less than I thought. Now I'm moving it up. I'm pressing up, but I can't go any farther. So that was 120. Maybe 20 more. Let's try 140. These are just random units, but we'll get it right. Yeah, look at that. So apparently, however big the paddle is right now, is 140. And now I'm pressing up. I think you can hear that. The turtle's not moving anymore because we checked. If he was past the top, stop him at the top. And we'll do the same thing for the bottom. This is exciting, trying to figure out all this stuff. I hope you think so too. So if new y is less than negative 140, this is the beauty of putting the screen right in the middle, because it's all symmetric now. New y equals negative 140. Yes. Okay, so I'm pressing up. It's calling, because it's listening. It's listening. It's calling move up. And it's doing all this. It's changing the new y, and it's making sure that it gets higher. Okay? Unless it's at the top already, and it keeps the new y right up at the tippy top. Okay? And we go to there. Move down does the same thing in the opposite direction. We change our y in the negative direction. We subtract. Until we get so far to the bottom that if we try to go any more, we'd be past the bottom. So we make sure we stop right there. Okay? Hopefully that makes sense what we're doing there. And that, my friends, is the paddle. we can almost play Pong. Maybe we should make the paddle a different color than the ball, but we can worry about that next time. So that is officially everything I have for you. Isn't that cool? So we've got a paddle, we've got a ball. All that's left is to bring them together, right? So that will be a job for the next lecture. So that is all I have for you now, and I will see you soon. I'll see you next week.